Hey guys, I'm Mrs. Delavecchia, and before we start, I want to remind you to take notes using the guided notes that are in your unit packet. Those notes will be a part of your grade. If you have any questions, write them down and we'll go over them in class. So let's get started. Alright, so in this video we're going to talk about angle relationships. So let's see what we've got. First, let's review. When you were in middle school, you probably already learned about these different types of angles. Angles, anything less than 90 degrees would be considered an acute angle. Anything that is exactly 90 degrees, we indicate with that little box in the corner, and that would be your right angle. Anything greater than 90 degrees is your obtuse angle. So what are complementary angles? If two measures add up to be 90 degrees, then they are considered complementary angles. And if they are adjacent and complementary, then they would automatically be forming a right angle because those two together would add up to 90 and they are connected, so the total would be 90 degrees. Okay, so in this example, what would the missing value be? We've got a right angle indicator and a missing angle, so we simply know that all of it equals 90. So the missing value, we would take away the 62 from 90, and we would get 28 degrees for our missing angle here. So if A and B are complementary, so what does that tell us right there? Angle A plus angle B are going to equal 90 degrees. So that's kind of the beginning of our equation. If angle A is 8K minus 1, so 8K minus 1, and angle B is 13K plus 7, what is the measure of angle B? Well, okay, finish this off. This angle A plus angle B equaled 90. So I can solve this equation for K, and then I will go back and substitute it to find angle B in particular. So adding my like terms, 13 plus 8, that is 21K. Adding 7 and minus 1, that's going to be plus 6, equals 90. Solve the equation. So we're going to do our two-step equation, opposite operations. That's 84. Divide it by 21. So K, 21 goes into 84 4 times. So our value for K is 4, but again, that's not answering the question. The question is, what is angle B? So 13 times 4 plus 7. And that would be 52 plus 7 is 59. So 59 degrees is the actual measure of angle B. So that's how that problem would work. All right, an angle is 29 degrees more than its complement. How many degrees is the smaller angle? Well, an angle and its complement we know would add up to 90 degrees. So we've got an angle and then another angle that is 29 degrees more than that. So this is the first angle, this is the second angle, and they need to add up to 90 degrees. Now we just work out the algebra, add the x's, subtract. Solving the equation, 2x equals 90, that's 70, that's 61. And then divide it by 2. X equals, that would be 30.5. So how many degrees is the smaller angle? Well, it would be 30.5 degrees. The larger one would be 29 more than that. So that's how something like that would work. All right, supplementary angles. Supplementary angles are angles that add up to 180 degrees. So complementary, 90, supplementary, 180. You need to have that solid in your head. In this picture, this is a picture of two angles that add up to 180 degrees. And remember how we name the angles: A, vertex of B around to C, that's that angle, and P, vertex of Q in the middle, and R. So these are naming each angle, and they add up to 180. All right, let's look at this one. Two angles are supplementary. If one angle is 111, how many degrees is the other? All right, well, if we've got an angle and another one, and they add up to 180 if they are supplementary, that's my equation. Subtract 111 from both sides, and that's going to leave me 69 degrees for the other one. All right, definition of a straight angle is just an angle that measures 180, so it's going to form a straight line. Now, a linear pair are two angles that are adjacent and they form a straight angle. So now, instead of just the straight line, we have an angle in between there. So angles 1 and 2 add up to 180. All linear pairs are supplementary because they all would add up to 180. So we can call this a linear pair. We can call them supplementary angles, adjacent angles. Now, not all adjacent angles are a linear pair, right? Because we could have these two angles. They're adjacent. Adjacent just means they share a middle side and they share the vertex. So that's all that adjacent is. But a linear pair would, the outside sides would form a straight line, and altogether it would be 180, so that would always be supplementary. Don't confuse supplementary angles with linear pairs. What's important is that all adjacent angles that form a straight line add up to 180. So we need to know, looking at this picture, all of these would be 180. So it's not a pair of angles, it's three angles, but they all add up to 180 degrees. All right, two angles are a linear pair. So what does that tell us? It means they form a straight line. So they add up to 180 and they're also supplementary. One angle is 26 more than the other angle. Find the measure of the biggest angle. Similar to another problem we had a minute ago. So pause, try this, and then see if you get it right. So we've got one angle. The other angle is 26 more than the first angle. So this is first angle, another angle. Find the measure of the biggest angle. All right, and the key information, they form a linear pair. That means they equal 180. So let's draw a picture of this. This is what we're looking at. So we've got an angle, and then the other angle is the bigger one. The one that you add 26 to. Okay, combine like terms. So you see the algebra here in geometry is pretty repetitive. It's not, you kind of do the same things over and over again with your algebra. All right, what's half of 154? Find the measure of the biggest angle. So x would be the smallest angle, so the biggest angle would be 77 plus 26. So 6 and 12, 6 and 7, that's 13. And 9, 10. So 77 plus 26 is 103. So the biggest angle would be 103 degrees. All right. Definition of vertical angles. Vertical angles are opposite angles formed by two intersecting lines. So straight line, it's important that you have a straight line and then the vertical angles would be here and here. Those are going to be congruent. And here another pair of vertical angles. I'm going to mark these like this. Okay, so across from each other, vertical angles are going to be congruent. All right, so in this picture, these are vertical angles. This is another way to mark congruency. 105 would equal 105. And here in a problem, we've got 133. Its vertical angle is this one. So this would also be 133. So we'll use that a lot in solving equations or finding missing angles. All right, in fact, here's one. Take a pause and try it. See if you get this right. All right, so this angle and this angle are vertical angles. That means they're congruent to each other. So I'm going to set up 2x plus 6 equals 96. Solve this. And x would equal 45. All right, how could we solve for all the variables? Well, we'll start by knowing this angle and this angle are vertical. So this is y is 76 degrees. Then these two, y and x, form a linear pair. So that needs to equal 180 minus 76 for the y. And that's going to leave us with 104. And then x and z are vertical angles, so they would be congruent to each other. These are a linear pair, so they're going to equal 180. So you can work that a couple different ways, but work your way around finding the missing angles. All right, all the angles that come from a single point all the way around are going to equal 180. So kind of when we talk later in the year, we'll be talking about circles, but the angles would all equal 360. So you could take some time and figure out all of those angle measures. And I think we're going to do that right here. All right. How would we solve this one? If you want to pause it a minute and give it a try, see if you can get them. I would start by looking here at this vertical angle situation. So that means this is 20 degrees. What else do we know? We know this is 90 degrees because we have a right angle marker. So then this is a linear a line. So all of these together are going to equal 180. Well, I already know 90 and 20. So that's 110. So this one's got to be 180 minus those two. So that leaves me 70 degrees here. Here, this is kind of interesting. If this is y, in the same problem, if that's also y, that would have to also be 20 degrees. So that's leaving this to be 110 degrees. And then if that's 110 and this is 20, then this z must be 180 because it's also, this is the other half of the linear pair. 180 minus 110 and 20, so that's minus 130. And that gets me 50 degrees for this one. All right, so that's all we had for today, and write down any questions you have and we'll talk about it more in class. Have a great day.